So let's start off with this problem. So in this problem, you'll observe that we have been given a kind of sum over here involving the binomial coefficients, which are represented by NCR, and then each term is getting multiplied by something which is looking like this. So if you look at this sigma function over here, you will find that we can write the given expression as like the sigma function can distribute over each of these terms. So we'll write this as NCR times 1 by 2 to the power of r plus, and this will go up till n, sigma of r equals to 0 to n, and then we'll have minus 1 to the power of n times NCR 3 to the power of r over 2 to the power of 2r, and this will go all the way up till the mth term. So that will have r equals to 0 to n minus 1 to the power of n times NCR times the mth term will be 2 to the power of m minus 1 divided by 2 to the power of m to the power of r over here, and this complete thing also will have the power of r. So we can just remove this minus sign from here and correct it out like this. Now if we focus on any one of these sigmas, such as this one, and if we just try to expand this and write out the terms involved over here, so you'll observe that this particular thing will expand as NC0 minus NC1 times of half plus NC2 times 1 by 2 squared, so on and so forth till we reach minus 1 to the power of n times NCn times 1 by 2 to the power of n. So if you observe closely, this expression is nothing but just the expansion of 1 minus 1 by 2 to the power of n. So that will just become 1 by 2 to the power of n. In a similar way, if we try to start from this second term over here, and if we expand that, so we'll be getting terms like NC0 minus NC1, and then when I put r as 1, so this becomes 3 by 4, and the next term will be NC2 3 by 4 whole squared, and go all the way up till minus 1 to the power of n times NCn times 3 by 4 to the power of n, which you will observe is nothing but just the expansion of 1 minus 3 by 4 to the power of n. That simplifies to 1 over 4 to the power of n. So in a similar way, if we expand the last term also in a similar fashion, so you will find that this entire sum is essentially the sum 1 over 2 to the power of n over 4 to the power of n over 8 to the power of n plus so on and so forth. So the mth term in a similar way will be 2 to the power of m whole to the power of n. Now this is a geometric progression. So if I were to write its sum, so I will say sum will be given by a 1 minus r to the power of n over 1 minus r. So if we just observe over here, the first term is this, so you write 2 to the power of n times 1 minus 1 over 2 to the power of mn over 1 minus 1 over 2 to the power of n, which simplifies to 1 over 2 to the power of n minus 1 times 1 minus 2 to the power of mn. So if we compare this expression with this given expression over here, you can just focus on these two. So you will find this part is matching with this part, so this constant k over here by comparison will be 1 over 2 to the power of n minus 1, hence a is my right answer.